Hey, what do you say? It's time to do some math today. Bring your pencil, bring your book, bring your. Sorry, I lost it there. That's the bath time story I tell my kids, but it's totally different. I ran out of fresh new lyrics. But hey, once again, this is Mr. McCarthy coming at you with lesson 3 in chapter 2, which is called Multiplying by Powers of 10. Today, when we are done with this lesson, and yes, it is a one-day lesson, you should be able to firmly, confidently, and loudly say, I can multiply whole numbers by 10 squared or 10 cubed. I believe in you. Don't forget to make sure that you believe in you. Today's vocabulary involves the words exponent, base, square, and cube. Hopefully some of those terms are at least a little bit familiar to you. And as always, you got this. All right, let's get rocking and rolling here. First and foremost, I'm playing on this video right now, but you should also be following along on the slides that are available in your Schoology folder. What you can do while I'm talking is you can actually write on your slides using your Chromebook tools. Or at a point like this, you can hit pause and watch this intro to exponents. I assume this is the Math Antics fella. So pause me, click on this video in your presentation in Schoology, and then come on back when you're done. I'm going to see if I can move my beautiful little head up where it belongs here. Look at that. All right, handsome. You stay right up there now. Out of the way. Okay, moving on. Now, what we're looking at today is kind of the similar thing we've been doing in previous days, is that we're looking for patterns. Now, an exponent is something that you use when you're multiplying a number by itself, okay? In the case of looking at the written version of 10 squared, 10 is your exponent. Oh, I lied. Oh my goodness. 10 is your base, and your exponent is 2. The base is the number being multiplied. For those of you that remember from the previous lesson, that's called a factor. And the exponent tells you how many times to use the base as a factor. I cannot stress highly enough. 10 squared does not equal 10 times 2. It does not. It says 10 is a factor twice. So what that means is 10, that's a factor because we're multiplying it times 10. 1, 2 times. Okay? So 10 times 10 equals 10 squared. Whoa. Oh, look at that. Ooh, naughty math and focus book. Naughty math and focus book right there. You can write 10 times 10 as 10 squared. 10 is a factor 2 times. And if you know that 10 is a factor 2 times and 10 times 10 is a factor 2 times, then that's going to equal what? Say it. I don't want to pretend I heard you there. 100. All right. Got it? Get it? Good. Let's buckle up and move on, my friends. Sorry about those misprints. I should call up Math and Focus and verbally shake my fist at them. So, taking a look here, we're going to use those exponents now and bases to do some multiplication. 23 times 10 squared really just represents 23 times 10 times 10, or 23 times 100. 23 hundreds is 2300 or 2300. And you can read along and see the same thing down here. 316 times 10 squared, 316 times 10 times 10, 316 times 100, 316 with those two beautiful zeros put there equals 31,600. Very, very natural progression from what we were working on yesterday. And guess what? I think this is even going to be a short lesson today, so you can, finish your math and do a little dance with your extra time. I'm going to give you a moment. If you need to back up the video and go see what I just breezed through there, please do. Otherwise, pause and solve these problems. As always, you can solve them in a notebook, or if you are following along the Google presentation or Google Slides that you're supposed to, you can actually draw right on your screen with your Chromebook and do these. You pause, I pause, you work, I work. We'll come back at it in just a moment and compare answers. Hop to it, friends. All right, did you get it? Great. Here's what I'm hoping for answers. Okay, remember you've already got a 0 here, so you've got 2 more there. And hopefully you can read my lovely penmanship, and that's what you got on your screen or in your notebook or whiteboard or sand or wherever it is you may be doing your work today, but hopefully a notebook. All right, let's shuffle on to the next slide. Now, that was 10 squared. You're really doing the same thing when you got 10 to the third as a factor. When you are using the exponent of 3, that's telling us that you were using 10 as a factor 3 times. 1, 2, 3. So when you say 10 times 10 times 10, you can write it as 10 to the third power, which you read as 10 cubed. Either one is acceptable. So 10 cubed, once again, does not equal 10 times 3. No. 10 to the third equals 10 times 10 times 10. 10 is a factor of 1, 2, 3 times, which equals what? You know what that equals. 1,000. Okay. So 45 times 10 to the third down here is just 45 times 10 times 10 times, or 45 times 1,000, or 45,000. 605 times 10 to the third is 605 times 10 times 10 times 10, or 605 times 1,000, or 605 thousands, or 605,000. Math is so rewarding some days. All right, once again, you pause, I pause, you work, I work. We'll come back at it together and compare answers, and hopefully we agree and we're just happy together forever. Pause and work. All right, let's see what we got here. 88 times 1,000 is 88,000. 560 times 1,000 is 560,000. 315 times 1,000 is 315,000. 7,008 times 1,000. You can do the 7,008 and then 3 zeros. If you remember that pattern. Remember, we're using patterns to solve, and that's 7,008,000. All right, oops, clear the screen, get my pen. All right, now, believe it or not, you can use these handy-dandy exponents to solve real-world problems. Oh, and this is literally a real-world problem. As someone who does my own projects, I've actually done tile quite a bit. So Mr. Wang wants to tile the front entry to his home. It is 36 square feet. Oof. Each square foot of tile he chooses is 10 tiles by 10 tiles. Okay, so in his entryway, it's 36 square feet. The number of tiles in each square foot is 10 to the squared. So what this is representing right here, my friends, this represents, you can get your tiles, like they actually come in like little sheets. So it's saying it is 1 foot by 1 foot, or 10 tiles by 10 tiles, right? So the number of tiles in each square foot is 10 squared, or 10 times 10, right? And if you need 36 of those tiles, because he needs 36 square feet, you're doing 36 times 10 squared, 36 times 10 times 10, 36 times 100, or 3,600. Mr. Wang needs to buy 3,600. But thankfully, no tile shop is cruel enough to sell those tiles in little 1.25-inch squares. They would very, very kindly give you a sheet of tiles that were glued together. So 3,600 tiles, but he'd probably only need to buy 36 sheets of tile. But that's just my own home improvement knowledge coming at you there. So 3,600 individual little squares in that 36 square feet. 36 times 10 squared is 3,600. And now you know how to do tile for your mom or dad's or grandma or grandpa's or brother or sister's bathroom, whoever needs it. All right, there are 10 to the third grams, or 10 cubed grams in a kilogram. How many grams are there in 15 kilograms? Pretty straightforward. You've got 15 times 10 to the third, 15 times 10 times 10 times 10, 15 times 1,000 equals 15,000 grams. There are 15,000 grams in 15 kilograms, or 15 kilos. Okay. All right, that's it. We don't have to do anything there but read. Oh, Mr. Wang, Mr. Wang. He must be a professional tiler, or he's just really working on his house. I've done the same thing. Same tile, different parts of the house. Why don't you read through and solve the Mr. Wang problem and the millimeters problem? I'll do the same, and we'll come back and compare work. Pause me now, and we'll visit shortly. Now, I think I should have clarified that he is using the same tile. Oh, why is that not working? You start being a pen right now, please. Same tile, so that means 10 squared per square foot. Okay? And he's got 48 square feet. Pause again if you need another moment. And here we go. We've got 48 times 10 squared, or 10 times 10. 48 times 100 equals 4,800 itty-bitty tiles. Bleh. But again, thankfully they come in sheets of 100. Finally, 10 to the third millimeters in a meter. How many millimeters are in 23 meters? 23 times 10 to the third equals 23 times 1,000 equals 23,000 millimeters. Moving on. Let's practice. Oh, Mr. McCarthy, get yourself out of the way. You work on this on your own. I'll work on this on my own. Let's both pause. We'll come back and put our brilliant minds together in just a few moments. Go. All right, friends, you got it? Get it? Good. I'm going to assume that you successfully went through this, so if I'm just going to go through, if I do something wrong, feel free to scream at the screen, and I'm going to feel free to ignore you because I can't hear you. That's how our relationship is now. Really, really a partnership. And I'm glad to be your partner in learning. And if some of you think I'm just some total weirdo, that's okay. Ask your 5th grade teacher. Most of them know me and probably can confirm it too. All right, now it's entirely possible that I made a mistake here, but I kind of doubt it. If I did, feel to scream at me and rant away, because I can feel free to ignore you. If something seems fishy, ask your teacher, but I think I've got this, so let's move on. All right, now we're using the metric system to convert our measurements. I want you to fill in each of these blanks using the chart up at the top. And then when you're done, our next slide will be a problem of the lesson, which your teacher will have you finish in whichever way they see fit. And you've also most likely got workbook A, pages 37 through 40, but again, verify with your teacher because it might be something moderately different. And as always, practice your IXL lessons that go with chapter 2. I shall pause, I'll go through these last bits of answers, and then I'll show you the last 2 slides. Go. All right. Have we all come to a civil agreement on these? I'm sure we have. Make sure you get a chance. Tell your teachers, especially like Edom or Forsland or Miss Kretsch, just how wonderful Mr. McCarthy is and how I enrich your lives. So that's just good stuff to share. We have just 1 or 2 more slides, and then I'll be able to wrap it up for you here. Here's your problem with the lesson, which you can now see. When it says, what is the value of each expression? It really just wants to tell us, what does this equal? And I don't know, I can't remember, I'm teaching off the top of my head, if we have done PEMDAS yet. I think we have, but I'm just going to give you a little bonus reminder because I'm feeling exceptionally generous today. Like beyond nice. Don't tell the 4th graders. I don't need them thinking I'm kind next year. They need to be a little bit scared. So there you go. That might help clarify things a little bit. So solve that, turn it in any way your teacher wants you to do it. Make sure you identify the pattern that they're looking for. And when you're done, you can go and do homework. I'll show the next slide, though it might not be the same for everybody. But as always, it's probably workbook pages and IXL. There you go. that looks to match up with what was in the book anyway. Again, these IXL codes are the codes that never change from year to year. And again, hopefully your teachers are using the skill plan function, or you're using the skill plan function when you go into IXL. Instead of looking for lessons by grade, look by skill plan, and it'll take you right into the lessons that go with this, the IXL lessons that go with this lesson of Math in Focus. If you're not using the skill plan button, or your teacher's not, make sure you talk to them and get your whole class on board, because it's super duper helpful. All right, amigos, that's all I got. I'm going to have to hit pause, process this, and produce yet another amazing math production for you. Have a lovely, lovely day. Send my best to all of your fantastic 5th grade teachers. You have amazing teachers wherever you are. I think I know just about all of them, and you're real fortunate to be working with the people that you are. So give your teacher an air high five from at least 6 feet away at some point, and tell them they rock. Peace out.